Good morning, dear students. Let's see problems on alternating series. Before going to the problems, let us see what is Leibnitz test. Now, Leibnitz test says that we consider an alternating series of the form a1 minus a2 plus a3 and so on, which in general can be written as sigma n is equal to 1 to infinity minus 1 raised to n plus 1 an. Now, this has to satisfy two conditions. What are those two conditions? Your an value will always be greater than an plus 1, and when you take the limits, limit n tends to infinity, an should be equal to 0. When these two conditions are satisfied, then we say the given series is convergent. Now let's see the first problem. The first problem says discuss the convergence of 1 minus half plus 1 by 3 minus 1 by 4 and so on. Now let's write out the given series. Now your nth term is an. So when you look into the first things, your numerators are same. Your denominator first term is 1, second term is 2, third term is 3, and there is alternatively plus and minus sign. So sigma an can be written as sigma n is equal to 1 to infinity minus 1 raised to n minus 1 by n. Now this is rewritten as sigma n is equal to 1 to infinity minus 1 raised to n minus 1 into bn. That is, the term apart from minus 1 raised to n minus 1 becomes bn. Now this is an alternating series. Now you know your bn is 1 by n, and this 1 by n is always greater than 0 for all n belonging to your natural number. Now let's find out bn plus 1. Replace n by n plus 1. So I'll get it as 1 by n plus 1. And when you look into the terms, you know 1 by n is always greater than 1 by n plus 1, which is nothing but your bn is greater than bn plus 1 for all n. Our first condition is satisfied. Now what is the second condition? We have to find limit n tends to infinity bn. So that is limit n tends to infinity 1 by n, that is equal to 0. Hence your two conditions are satisfied. Therefore by Leibnitz test, sigma an is convergent series. Now let's go to the next problem. Here your given series is 1 by 1 into 3 minus 1 by 2 into 4 plus 1 by 3 into 5 minus 1 by 4 into 6 and so on. Now let's write the nth term. So nth term will be sigma n is equal to 1 to infinity minus 1 raised to n minus 1, 1 divided by, now let's take all the first terms here. It's 1, 2, 3, 4 and so on. So nth term becomes n, and when I take the second term, the first term is 3, which means to say it is more than 2 terms of the previous term. So it is 3, 4, 5 and so on. So nth term becomes 1 divided by n into n plus 2. So this is rewritten as sigma n is equal to 1 to infinity minus 1 raised to n minus 1 into bn. This is again an alternating series. Your bn value is 1 divided by n into n plus 2. This is greater than 0 for all n. Now let's find out what is bn plus 1. Replace n by n plus 1. So I get 1 by n plus 1 into n plus 3. And you know 1 by n is greater than 1 by n plus 1, and 1 by n plus 2 is greater than 1 by n plus 3. When I combine them, I will be getting bn is greater than bn plus 1 for all n belongs to natural number. Now limit n tends to infinity bn is equal to limit n tends to infinity 1 divided by n into n plus 2. That is, when n tends to infinity, we get 1 by infinity, and 1 by infinity is equal to 0. Since both conditions are satisfied, by Leibnitz test, the series is convergent. Now let's go to the third problem. Now this is 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on. So sigma an is sigma minus 1 raised to n plus 1 divided into 1 by 2n minus 1. This 1 by 2n minus 1 is taken as bn, and they are an alternating series. Replace n by n plus 1, we get bn plus 1 is equal to 1 divided by 2 into n plus 1 minus 1 becomes 1 by 2n plus 1. Now you know, since your 2n minus 1 is less than 2n plus 1, let me take the reciprocal. When we are taking the reciprocal, the inequality changes. So I get 1 by 2n minus 1 is greater than 1 by 2n plus 1, and these are nothing but bn is greater than bn plus 1 for all n belongs to n. Now this is our first condition. Next, limit n tends to infinity bn is equal to limit n tends to infinity 1 divided by 2n minus 1 is 1 by infinity, that is 0. So since both the conditions are satisfied by Leibnitz test, I say the given series is convergent. Now next problem. This is very important. So it is 1 minus 1 by 2 cube into 1 plus 2 plus 1 by 3 cube into 1 plus 2 plus 3 and so on. So when I am writing it in summation an, it becomes sigma n is equal to 1 to infinity minus 1 raised to n minus 1. Now if you look here, first term is 1, second term is 1 plus 2, third term is 1 plus 2 plus 3. So nth term will become 1 plus 2 plus 3 and so on plus n divided by, now look into the denominator. The first term is 1 cube, 2 cube, 3 cube, 4 cube and so on. So nth term will be n cube. We all know that sum of n terms of a natural number is given by n into n plus 1 by 2. So it becomes n into n plus 1 into divided by 2 into n cube. 1 n gets cancelled. So we get n plus 1 by 2n square into minus 1 raised to n minus 1. Now here our bn is n plus 1 by 2n square. This is again alternating series and our bn is greater than n for all n value. Let's find out bn plus 1. Replace n by n plus 1. So your bn plus 1 becomes n plus 2 divided by 2 into n plus 1 whole square. Now here there is a little change in the problem. We will take Vn is equal to 1 by n. So when I find sigma Vn, this is sigma 1 by n, this becomes convergent by P series as P is equal to 1. Now what is a P series test? Sigma 1 by n power P has three conditions. If P is greater than 1, we say it is convergent. If P is less than or equal to 1, we say it is divergent. This we have already studied. Now let me finish Pn minus Pn plus 1. This is Pn value, Bn value. This is Bn plus 1 value. Let me take LCM. Our LCM is 2 into n square into n plus 1 whole square. So cross multiplying, I get n plus 1 whole cube minus n square into n plus 2. Now the first term is of the form a plus b whole square. Expand it, resimplify it. I am left with n square plus 3n plus 1 divided by 2n square into n plus 1 whole square. This entire term is positive. So for any value of n, the given term becomes positive. Therefore, Bn is greater than Bn plus 1 for all n belongs to n. Now limit n tends to infinity, Bn becomes limit n tends to infinity, n plus 1 divided by 2n square, out of which I will take 2n common and n, split this into two terms. So when I split it into two terms, n by n square becomes 1 by n plus 1 by n square. When I apply the limit, 1 by infinity becomes 0. So half into 0 is 0. Hence, limit n tends to infinity, Bn is equal to 0. Now by both the conditions, using a Leibnitz test, the series is convergent.